Hello, and welcome to the Top 5 Performance Tips to Supercharge Your Android Apps webinar produced by Crittercism. So welcome everybody, and thank you for joining. We really appreciate you taking the time out of your day, and we've been really excited to do this webinar. So just to get things started here, I'm going to quickly talk you through the agenda. We're going to briefly do some introductions. Then we'll hand it off to Godfrey Nolan, who is an Android performance expert. We're very privileged to have him here with us. He will cover topics here like streamlining your UI, how to shrink your APK size, identify memory leakage, how to profile your code, and then from Crittercism here, we'll show you ways to measure your app's performance in the field. And then after that, we'll have a Q&A session. Just a little bit of housekeeping here and introductions. So again, we're very privileged to have Mr. Godfrey Nolan join us. You can find Godfrey on Twitter at Godfrey Nolan. Godfrey is the author of multiple books on Android, including Bulletproof Android, Android Security Essentials, Android Best Practices, Decompiling Android, and Decompiling Java. If you notice that book in the middle there, Android Best Practices, as part of this webinar, we'll be raffling off 10 copies of the actual book at the end of the webinar. So you need to be still attending at the end of the webinar, and at the end we will go through the attendees and randomly select 10 of you to receive that book. So when we do that, we'll let you know, so please stay on through the end to do that. Briefly myself, I'm Alex Gaber, a developer evangelist here with Crittercism, work with our customers to make their apps work better, faster, and smarter. For this webinar, we do have a hashtag, so we'd love for you to tweet. We'll be actively tweeting throughout the webinar. If you put in the hashtag Android Performance, we will be monitoring for that, and look forward to retweeting you if you put out any tweets there. Just also to mention, as far as housekeeping goes, as far as asking us questions, we welcome all your questions and feedback throughout the webinar. There is a chat interface as part of WebEx, so please feel free at any time to submit your questions to either myself or Godfrey Nolan, and we'll be monitoring that closely for the next hour and address those. If we can't address them quickly as we go, we will. Otherwise, we will wait to the end to address some of the more complicated questions. But again, please feel free to use that WebEx chat interface and send us any questions or thoughts you may have, or feedback we welcome as we go throughout the webinar. So just as we get started, just to give a little bit of Crittercism background here. Crittercism, it has mobile in our DNA. We're all mobile app developers here, and we build tools to make our mobile app development lives easier. Another thing, at Crittercism, we are the backbone for a lot of the largest apps and the mobile apps in the world. So we operate at an enormous scale. We're monitoring, on average, over 4 billion app instances a day. We've analyzed over 250 billion app launches. We are across the globe, and as you can see here, we have some very prestigious investors which have helped us grow and scale our company to support our growing customer base. So really quick, what we want to address is, why are we here today? Poor app performance is one of the biggest problems in apps and causes users to do things that the app developer never intended. So we did a survey here at Crittercism at the end of 2013 and asked the question, how do customers react to poor app performance? And resoundingly, 65% said they uninstall the app. Some of those told a friend or person. A fifth of those people contacted the developer and told them. Only 1 in 10 actually take the time to go put a negative review in the store. So the biggest thing here to look at is silent defection. When your app does not perform well, your users simply uninstall it, and they don't tell you and help you fix it. So how do you address that? So that's really the premise for why we're here today, and why we're going to have Godfrey Nolan here walk us through some of the best practices for optimizing your Android performance. So without further ado, I would like to welcome Godfrey Nolan to our webinar today. And at this point, I'm going to go ahead and hand over controls to Godfrey. Godfrey, welcome. Oops, standing by here. Looks like Godfrey, we need you to rejoin the audio. Okay.
I've got it now. Of course, I had it on mute.
There we go.
Okay. Can you see my screen?
Yes, we can.
Okay. First of all, thanks for everybody for joining today. I wanted to thank Alex and the rest of the folks at Crittercism for letting me go through this talk. My name is Godfrey Nolan. I'm president of Reese LLC, which is a mobile and web development company. We're based just outside Detroit in Troy, Michigan. We have quite a few mobile clients in the healthcare, financial, and a couple of the consumer-facing. And we do a lot of what I'm going to talk about today is stuff that we've figured out as we've been helping these clients over the last couple of years. We do a lot of work for telecommunications companies too, which is where this call center app that you're staring at originated. I'm also the author of a number of books for A-Press, and I'm currently working on one for Pearson Publishing, which is called Bulletproof Android. And I'd like to talk to you today about some of the research I've done while looking at Android performance for the Android Best Practices book, which was published by A-Press late last year. This is also a really nice fit for some of the work we've done in the past at Reese, where we used to have a website performance optimization practice. So back in the day, the metric for websites was that measured on the web server, 95% of web pages should be returned in a second or less. The raw stats, such as the number of page hits and page timings, were all there to see in the log files, and the trick for optimizing a website was to optimize the slowest, most visited pages, and that gave you the perception of a faster web server. And just like mobile devices, perception is reality when it comes to performance. So in our practice, we used to find speed increases of up to 10 times in the worst performing pages. It was pretty common. There was either indexes that weren't in the database or somebody was doing something strange with their logic which could be easily fixed. So every week we'd run a report which would show us the most visited, worst performing pages, and over a month or so we could essentially transform the web server speed using this wash, rinse, repeat type approach. Android, on the other hand, really isn't that simple. In Android, there is no 95% of pages should be returned in a second or less metric. There really isn't any consensus on how responsive an app needs to be. We're starting to get there, but we're not there yet. And anyway, the metric would probably also vary from one device to the next. It's also a lot harder to measure how long each activity takes, as there is no log file with a handy-dandy time-taken token that you can use. Ideally, what we're looking for is a good load testing tool with some sort of reliable time measurement. And if possible, we'd like to build it into a continuous integration server so we could see the regression test reports and identify if something is all of a sudden taking dramatically longer than it was in the past. Most of you are probably aware that Google has an excellent list of Android performance tips, which you can find on the Android developer website. These are coding tips, and a couple of people have gone to the trouble of measuring how effective they are using system nanotime. The Google list, in my opinion, takes a very fine-grained approach to Android performance. But the 5 tips that we're going to talk about today take a much more top-down approach, and we'll be looking at the timings in seconds and milliseconds rather than in nanoseconds. So as we said earlier, the tips are streamline your user interface. We're going to look at the hierarchy viewer. We're going to shrink our APK. A tip that was given me at one of the conferences a while back was that not only is obfuscation something that's really good for protecting your code, but it actually decreases the size of the APK, so much so that you actually get much better performance on download, and you actually get better performance from the app itself. We're going to talk about identifying memory leakage issues, and then profiling your code, and then we'll hand it back over to Alex so that they can talk about measuring performance in the field. A lot of the apps that are out there are client-server apps. So while the first 4 we'll look at, as I said, we'll look at how to squeak the most performance that you can out of the client. You really should be looking at the network performance too as well to make sure that whatever's happening on the back-end server is fast enough, and whether you need to do anything on the back-end to make sure that it's got as much memory and as much speed as possible. Okay, so as I said, I'm going to talk about the first 4, which are all client-side optimizations, and Alex will talk about the last. We're going to use this Call Queue Manager app for testing. It has 3 screens, a login screen, a list of call center queues in the middle, and agents in each queue. And this is hitting a back-end call server, which just happens to be a developer sandbox. The code for this is available on GitHub. It's also available from downloading from the A-Press site, and that has a lot of the tests as well. So what I'm going to do now is we're using Calabash to do the testing, and Calabash is basically Cucumber for Android. And for those of you who are not familiar with Calabash, what it does is it sets up use cases in a given when then format, and then executes the test cases against your application. So I did this earlier. I just want to run through this real quick. I want to do that. What I want to do is to show you a video of something that I did earlier. I don't want to be waiting too much time for the emulator. Let's make it go fast. So what this is doing is it's going through the different scenarios given when a user is in the login screen. When they enter the login credentials, then they're going to see a list of call queues. Speed it up a bit more. So as you can see, it's just entering the data now. And what I'm using Calabash for is every time that we make a change, we run Calabash against this, and it tells us what the speed is. You can see the username and passwords are there too as well. If you want to play with it later yourself, you're more than welcome to use our developer sandbox. Okay, so what does this look like in the actual code? Okay, the features are in the feature file, so we have two screens here. This is just the login feature file. So you can see the format is here, given I am a call queue manager screen. When I enter my username and password, then I'm going to see the call center screen. The other interesting thing about Calabash that we really like is the fact that you can make it table-driven, which means that you can do lots of tests and test for lots of different scenarios, success scenarios as well as failure scenarios, all the time making it table-driven. Okay. Let's go back to the presentation. So the first tip is streamline your user interface. Most Android apps, as we said, are some variation of a client-server app. So we have a back-end server with a web service API that sends information to the Android client app, so it can be seen on the mobile device. In our example, the back-end server for this call center app is a voice over IP server from a company called BroadSoft, which manages the call center traffic. The majority of an Android app code is for displaying the user screens or activities with information retrieved from somewhere else. Needless to say then, if you can improve the speed of your user interface, then your user experience is going to be dramatically improved. So the best tool for seeing how your app's user interface is performing is the hierarchy viewer, which you can see here. It gives the developer an excellent picture of how long each item in your layout is behaving and how long it's taking to display. So in this tip, what we're looking at is what happens when an Android developer relies too heavily on linear layouts when designing an app. Layouts are created in the layout file in the resources folder, and it's easy to design using linear layouts. In fact, back in the early days, that was the default. The default has now changed to relative layout, so it's getting better. But the issue that you have with linear layouts is, unfortunately, in anything but the simplest of layouts, linear layouts can quickly become nested and slow to draw. A more efficient way is to lay out your app is to use the relative layout, which uses less objects to draw the same layout. And because it isn't nested, it's much quicker to draw. As you can see here, the login screen is really quite basic, but the structure is not as flat as it would be with a relative layout. So if you move to a much more relative layout screen, we decrease the number of objects, and as you can see, the relative layout of the hierarchy is much flatter. So we're going to look at some of the Calabash timings. So the Calabash timings for the before and after for the call center application login screen. And here you can see that there is a 26-second improvement on the all-important initial run. Otherwise, the changes are in the ranges of 3 to 8 seconds. So even on something as simple as our login screen, there's a nice bump in speed on the first load, the all-important first load, and improvements will be better on apps with more linear layout nesting. Easy for me to say. The way that you get to the hierarchy viewer, we go back to Android, well, what I want to do first is I want to see if I can run the code so I can actually get the app being exercised so that I can see it in the hierarchy viewer, because otherwise it may not turn up, it may not show up. This is what it looks like in the hierarchy viewer. You can move around. Don't know how easy it is to see with WebEx. But essentially what you do is you attach to whichever page that you want, and it tells you each of the different objects and how long each of the different objects are taking. Okay, the second tip that I want to talk about would be to, oops. Oh, it looks like my screen as the hierarchy viewer is killing it. Hold on a second while normal service is resumed. Sorry, Alex, could you perhaps take back the screen?
Sure.
Okay.
Okay.
Okay. And it looks like I'm back again. Sorry about that. Could you give it back to me again?
Yep.
The demo gods are crazy today. Okay, so the second thing I want to talk about is shrinking your APK. So obfuscators are typically used for safeguarding your code against reverse engineering. We do a lot on decompiling Android. I've written a book about it.
Hey, Godfrey. Godfrey,
yep.
Really quick. You need to reshare your desktop. It looks like it didn't go through yet.
Okay. Yeah, that would help.
Great. There we go.
Okay. Sorry about that, everybody. So as I said, obfuscators are typically used for safeguarding your code against reverse engineering. We do a lot of work auditing different apps, and it's nice to see that a lot of people are using it, a lot more certainly than 12 or 18 months ago. But one of the nice benefits of obfuscation is because you can you see the screen? I'm seeing somebody saying they can't see. Hello, can you see the screen, Alex?
Yes, yeah, enable
okay,
ProGuard.
Great.
Yeah.
I'm on ProGuard. So the way that obfuscators work is that they obfuscate your code by replacing the strings in your app with short one-letter characters. They remove any unused classes and perform small optimizations that are hard to reverse engineer. But obfuscators are often overlooked for their performance side effects. The very fact that they shrink your APK by 50 to 75% can provide some impressive download and execution improvements. And if you carefully pick and choose what classes to remove, such as logging or indeed any of the classes that you need in development but not in production, you can push the improvements even higher. There are several obfuscators out there. There's ProGuard, which ships with the Android SDK, but there are also other ones like DexGuard from the same people who brought you ProGuard. And there are Dasho, which are more commercial versions, which also provide much greater optimization, obfuscation, and shrinkage. But to enable ProGuard, essentially what you do is uncomment out the following line in the project properties file. It doesn't really get much easier than that. The main thing to look out for is that ProGuard will only work on production or release apps, and it doesn't obfuscate debug builds. So from Eclipse, you have to go to the Android tools and export assigned application package. So if we go back to Java, and hopefully it doesn't close everything down on me.
And Godfrey, if I may just quickly interject while you're doing that, I think the reason, and maybe you can confirm why ProGuard is just used for really release versions of the apps is because when you're running in the emulator, you're debugging and you're able to monitor your debug console right there in your IDE. Whereas what we see is when you enable ProGuard for your release apps, that will enable your code to be symbolicated so that when you do have these production errors in the wild, you get more information back because of using ProGuard, and that's kind of the reason why it's used for production and release. Correct?
Yep, that's correct, because essentially what happens is that it breaks the link between what the original code method names are and renames them to A, A1, B, B2. And if you're using an obfuscator, you actually have to use a mapping file along with your stack trace to get back to where the bug actually happened. So that would make perfect sense that it only works in the production, doesn't work in the debug. So in order to get it to work, essentially what you do is you go to Android Tools, Export Signed Application Package, and then assuming that you have a key store set up, you enter your information. And I'm assuming that it's something similar in the Android Studio, but it's just an extra step that a lot of people miss if they're not sure exactly what to do with the obfuscation. And look at the trace as well, and always check your final app to make sure that it's actually done the obfuscation. There are other things you can do as well if you want to be a little bit to shrink even more. If you go into the ProGuard project text, ProGuard is actually set up now these days specifically for Android projects, but there are still a lot of configurations that you can do on top of what ProGuard does out of the box. Let's go back to the slides again. So what did we get? So the file size, I'm not showing it here, was reduced by almost 20%, actually a bit more, 25%. It was 1106 to 820 kilobytes for this one. And although much of the time in this app is spent communicating with a back-end call center server, a voice over IP server, we're still seeing, after the first run, a 15-second improvement in our tests once the app is up and running. Okay, so next what I'd like to talk about is identifying some memory issues. So one of the least understood performance issues is how garbage collection works in Android apps. So the Android operating system is a virtual machine called the Dalvik virtual machine, or DVM. Android apps don't really run as compile code, but are instead interpreted as the app executes. So usually as activities and objects are no longer needed in the DVM, they are recovered by a process known as garbage collection. But there are plenty of times when activities or processes can be orphaned and do not get garbage collected. And if you have enough of these in your app, then the amount of memory or heap space your app uses will consistently grow. So it's important that your app does not have any memory leakage issues, otherwise it will become sluggish and eat up any unnecessary battery resources even when your app is no longer in use. So to simulate an unusually large heap, I added some code, which I'll show in a second. And the way that you track it is that the Android SDK comes with a tool called DDMS, or the Dalvik Device Management System. We can see lots of information on how your app is performing using DDMS. So you open the DDMS, in this case from within Eclipse. Click on the name of the app in the left frame and to see how much memory is being consumed. And if you click on the Cause GC button, it initiates this garbage collection. So you repeat this until you see the memory growing over time. And this allowed us to show that this was the before and this was the after, which showed us that the number of objects was decreasing. We repeated this until we had a well-maintained heap. So not surprisingly, as we had a large number of heap of objects that were not being garbage collected, the before heap values were a lot higher than the post heap. The heap has a dramatic effect on making the app very sluggish, which we can see in the calabash timings. So across all the 3 different runs, and we run these multiple times just to see if we're getting an average. But this was the increase in performance that we got just by looking at the heap. Okay. Profiling your code. The Android SDK comes with another tool called TraceView, which can be used to profile your code. There are 2 ways to use TraceView, one at the macro level and one at a much more micro level. I prefer to use it at the micro level. We'll talk about that in a second. So we begin by using TraceView to get at the macro level to get an overall feel for what your code is doing and hopefully identify any significant issues in your app. Once we know what the slow methods are, we can then zero in on any potential issues in your code by instrumenting the code with trace statements, and again using TraceView to see how long each block of code takes to execute. So in order to get TraceView working, you'd open the emulator and install the call center app, start up DDMS as before, and then you click on the call center app and click on start method profiling that you can see here. The secret then is when you click on stop method profiling, you want to make sure that you only really do that for 2 or 3 seconds. There's not much point in start method profiling and let it run for a couple of minutes. What you do is you automate tests using Calabash or whatever your favorite tool is, and then you do start method profiling, and then 2 or 3 seconds later you hit the stop because there's simply too much noise otherwise. When you hit the stop method profiling, it will automatically open up TraceView so you can see the times for each method. Now for me, one of my developers here is really good at reading the top-level trace views. I prefer to use the trace command and zero in on a method because there just seems to be too much Android OS noise and very little signal for what I'm trying to do. So thankfully, trace view also allows you to take more of a directed attack, so you can add trace statements to your code to zero in on any of the problem areas. So for example, if we know that we have this class here which is causing our performance issues. We know because we put it there. So if we put the start method tracing right before it and stop method tracing, that then puts a trace file that's stored in your SD card. That needs to be pulled using the ADB command, so an ADB pull command for the trace, or you can remove the SD card and put it in your PC or Mac. You can then open the trace from Eclipse to see the trace view, or you can run trace view from the command line. So in this example here, it's now much more obvious that what class is causing the problem, and by fine-tuning that class, I can then make sure that, like we went back to the start, where we're looking at the worst performing activities, worst performing classes, and fixing the offending ones, and then gradually over time improving the performance of our app. Okay, I'm just going to take a quick look to just to show you what TraceView looks like. So this is the standalone version of TraceView, and this is using a trace file, so you're just running it from the command line, and it's the same timings that we see in the slide. Okay. And with that, I'm going to hand that back to Alex, and I look forward to your questions at the end of this talk.
Thanks, Godfrey. That was excellent. Just 1 second here while I regain control of the screen. Okay, great. So excellent. That was extremely useful information. I know a lot of my Android apps, I've made many of those mistakes over the years, and those are great best practices to learn from. So I think what we're kind of segueing here is, Godfrey gave us some great examples of how to optimize our client-side development for our Android app, and how we do that as we're in dev and test and building out the app and optimizing our UI and our overall code for performance. But another area that we also look to focus on is where we kind of look at the life cycle of the mobile app from build, test to deploy. It's focusing on the performance once you've deployed that app, and how do you optimize the performance once it's out there. And in areas that we can't really test prior to launch, things like app crashes and exceptions that are out of your control, or if your app is dependent on APIs, where we've learned here Crittercism on average, the average Android app today is consuming over 5 web services or APIs in their app. Things like unresponsive apps just because of slow APIs, transactional errors when your app just fails, and then also due to geography. We see that not every cell phone carrier is made the same, and we see a lot of different variation there. So some of the big issues here that we look at is one use case here. And this is just a sample use case that did come from an actual Android app out in the wild, where they had a free version of their app and a paid version of the app. The free version, they used mobile ads to monetize it, and then the paid version, they took out the ads. So the paid version did not have the third-party ad SDK. And a fascinating data point here was the free version, because of that third-party ads SDK, had a greater than 3% crash rate for the users, whereas the paid version, without the third-party ads SDK, had a less than 1% crash rate. And so this is just kind of one example here where an app developer found that their performance of their app was significantly impacted by integrating that third-party SDK. So when we talk about monitoring performance for your Android app once it's out in the wild, right here is just kind of a lot of the metrics and analytics you can look at to monitor that app for performance, to really understand how it's responding in the field and what users may be suffering different errors. So with that quickly, I'm going to jump to a quick demo here and just show you some of these things live, how they work, and how you can optimize performance for your app once we're out in the field. So now, just to be clear, I'm talking about performance of your app in terms of the performance factors that are impacted by any web services or APIs that your app is consuming. So here I'm actually looking at the Crittercism dashboard, and I can see here, and this is just data aggregated and anonymized across some of our apps. This would be a sample app for Android that's consuming a lot of different web services. We have a lot of third-party ad SDKs in here. We may be hitting other APIs for data consumption or authentication for users so they can sign in with Facebook or whatnot. But what we give you here is viewing all the latency across these services for them. We show you error rates, request volume, and data in and out. But interestingly to me, I want to look and see how is my app getting impacted by, say, the Facebook API. So as I tab over here, I want to look at just specifically, say, the Facebook API and understand how that may be affecting my user's experience and performance of my app. So as I look at the latency for this API here, I can see I'm having a few spikes. And I see that, oh geez, I'm having a couple here that just creep over 500 milliseconds. And this is when I think I really need to monitor and improve that. So what I'm able to do here is say I want to alert myself when the latency exceeds the threshold of 500 milliseconds, and it's for the Facebook APIs, and I can even get closer down to a specific endpoint, and then I can choose who I want to submit that to. In this case, it's just a sample company. I can filter on version, I can filter on a certain device, carrier, or OS, and create that alert for myself. So whenever that Facebook API exceeds 500 milliseconds, I'm alerted. So then I can figure out ways within my app to either prefetch those API calls or decouple them further from the user interface so that the user experience is not impacted by some of those slow responses. So as I go back here, I also want to maybe look at performance across the globe. So as I mentioned, not all carriers are made the same. So we can see here with our app where latency may be really high in certain areas. So we can see here in certain countries in the world, our app is really achieving really high latency. And one other area of the Android app development is when you're doing your localization of your app, you may choose for some of these countries to say, I'm not going to load those certain graphic files or images for those countries in your localization within Android Studio, because you've learned here from the feedback of your performance monitoring that those countries are suffering, and you want to improve the user experience so that your app is just as good there and fast. But so you may choose to remove certain elements of your app for those certain countries. So this kind of data is extremely valuable to understand how your app's being impacted by these APIs and how you can improve through that feedback loop. Another thing we look at is device trends and where you may be having issues there and how you can also optimize the performance of your app. So here I may see things like, if I'm looking at latency, I can see here, for example, under Android 4.4, I'm actually seeing the highest latency. Here it's not a drastic difference, but as I want to tune my app, I may want to know where to make my improvements. So I can see for Android 4.04, I have 384 milliseconds, and that may be because of the OS, it's something. And I can also see request volume, which generally can be referred to as how many users that's impacting, or here I can see it's 10% of my user base. So as far as bug fixing prioritization, I'd be able to know here that if I want to fix 10% of my users and improve their experience, I would want to analyze and further fix that. And other things too here I can just see, again this is just for the US here, carrier trends, but I can see maybe a certain carrier has a certain spike. In this case, a certain carrier has 340 milliseconds, and so these are things I may want to optimize again through the client-side development with my localization tools in Android Studio. I can change these things in my app so that when it's on a certain carrier using the network code, I could change certain factors of my app and not deliver certain graphic files or not make certain API requests based on the knowledge I'm getting here. And then also just to mention device trends. We all know that not all phones are made equally, and you may need to deal with certain issues. So here I see Samsung Galaxy S2. Well, it's only 2% of my users, but they do see a really high latency there. So for some reason, the S2s are not really handling my app well. And again, this is just giving you direct feedback how you can improve your client-side code to really optimize and get these latencies down and provide that exceptional user experience. So that's really just what we give you here, to just give you that feedback loop to understand how to improve your app's performance and viewing these aspects of performance as trends across your lifetime of your app, and how to respond. Where is my app being impacted the most for performance, and what things can I fix that would address the largest % of my users with the least amount of effort on our development side. So that's basically the quick rundown here of how to improve the performance by monitoring your app and the APIs that your app's consuming. So with that, I want to go ahead and take it to the questions now and see what questions we have here. So let me go to the chat window here. Okay, so I do see one question here, and this one may be more for you, Godfrey. But someone asked, what's the difference between an ANR and a crash? And that's an Android not responding. Godfrey, do you want to handle that one?
Well, an ANR is just essentially because your screen is taking too long to respond. So if it takes over 8 or 10 seconds, Android, the OS is just going to take over and say Android not responding. A crash is when there's a defect in your app which causes your app to collapse, to crash. But an ANR is just the Android OS essentially saying, okay, you've taken long enough, you're getting no more time.
Yeah, and I think also, Godfrey, I've seen some of my apps, I got ANRs just because I had a hanging API call that was either trying to parse too large of a payload. Their API was not paginated, did not let me pass a pagination parameter, and so I had to get the whole payload. And I've had that cause issues for the ANR aspect of it. And I think, it gets me to respond to that question too. And an ANR is not fatal. It's just a timeout, and can often be because of the API performance of it.
ANRs can appear on some devices and not on other devices. So if it's an old Droid, the OS won't be fast enough because of the processor, and you're more likely to get ANRs on older devices.
Got it. Okay. So great answer. And then we do have another question here, Godfrey, and this was directly to you. Do you ever use the MAT tool for memory analysis, the MAT tool? Do you have any tips or tricks for using that tool for memory analysis?
Yeah, great question. I use it all the time. If you're doing memory issues, what happens is that it creates a HPROF file, which is a heap file, which is impossible to read, and the best way to read it is to use the memory analysis tool from Eclipse. I believe we say in the white paper, we mention it, if not it's in the book, about how to download it and how to install it. It comes with a bunch of canned reports, and certainly if you're into memory issues, we didn't have the time to show it today, but the MAT tool, the MAT tool, is the way to go.
Okay, great. One other question here that came up, I guess I don't know if it's directly related to everything today, but a user just asking, do you recommend using the new Android Studio, which is still in beta, as far as I understand, or versus the Eclipse? Have you found, what have you found for stability for the new Android Studio versus the old one, and has it impacted the performance?
I don't think it's impacted the performance. We haven't got 100% success with Android Studio yet. We're kind of waiting for the 1.0, but most people are moving to it already, so we're probably a bit behind the curve there. But certainly if you want to use any of those MAT tools that we just mentioned, you can't use them in Android Studio as far as I know, because they're an Eclipse tool. But really at this stage, it's what kind of a Luddite you are, or whether you want to be the first person to try the latest and greatest. We're really at that stage. But we've done projects with developers here with Android Studio. It's been successful. Personally, I'm still on Eclipse because I'm waiting to see the 1.0 Android Studio, which hopefully may come out at Google I/O.
And I'm an early adopter myself, but I'm still using Eclipse as well, Godfrey, because I had a lot of trouble with the new one, Android Studio. So I'm with you on that. We did actually get another question, and this question is, you mentioned Calabash, and the question is, have you come across other tools like Robotium, RoboSpace, or Appium for automated testing, and do you prefer any over the others?
There are lots of tools out there, and they all fit into different spaces. On the Cucumber side, I like Cucumber because I like the given when then format, because that helps with defining requirements. But there are other versions. Calabash is probably the main tool that people are using for Android testing using Cucumber, but there are other versions out there. There's Gamelan from Cheesy Morgan, if you want to search for that, which is quite good if you prefer not to use Calabash. But Robotium and RoboElectric, I'm a big proponent of RoboElectric too as well. They're more on the side of the unit testing and using TDD as opposed to Calabash. So Calabash is what's known as BDD, behavioral driven development, and RoboElectric would be more on the TDD, test-driven development cycle. So they're complementary. Both of those I think are great. Certainly RoboElectric and Dagger would be things that we use all the time when we're trying to do our testing.
Yeah, no, that's great. I'll mention too, we actually hosted here at Crittercism offices about a month ago. We had the San Francisco Android Test and Performance Meetup group here. We had the test lead, formerly Macy's.com, for their mobile apps. I think now he's at OneLogin, Melvin Langorin. And he came here and spoke and gave demos of using Calabash as well, and mentioned many of these. And I know that I've used Calabash, and we use it here in Crittercism to test some of our sample apps. I think, as Godfrey, you mentioned, there's different differences to each, and some are better for certain things. So we do have more questions coming in here. 1 second here. So let's see here. So we have a question, just more follow-up here on the MAT, Godfrey, probably again for you. The question is, Eclipse has MAT. Does Android Studio have nice features you wouldn't find in Eclipse?
I'm afraid you're asking the wrong person. I don't know enough about Android Studio. Sorry.
Okay.
I'm sure it does. I think the main thing it has that over Eclipse is the build system is Gradle, which I prefer over Maven. That's probably about it for the moment that I know about.
Yeah. One thing when I did play with Android Studio, I noticed that the emulator actually had some really nice features, and it actually gave you ways for again, just for tests within your emulator, where you could test your app on a 2G network. And the emulator had a lot of nicer features than the older emulator, as far as creating some simulation environments like on 2G in a certain geographic location. So that seemed like some nice features in Android Studio. And then also, yeah, from Gradleware, Android's now using Gradle, which has really become the #1 build tool for any Java web applications. Now that they're getting into mobile as well. So let's see. Interesting question here. What percentage of your development time do you spend on testing, and what is the usual coverage you aim for?
The way that we set up our teams here is we have usually 2 developers. We have an automated tester, we have a scrum master, and then sometimes the automated tester does some of the BA side when writing the unit tests. I would say that we have a full-time tester that's on the Scrum team, so he's one person out of a team of 4 or 5, or she is in our case. And then coverage, I'm assuming you're meaning unit testing. Usually when we're looking for unit testing on Android, it's much harder to do unit testing on Android, so we tend to go for the 60%, 70%, rather than in normal Java when we'd be closer to the 80 or 90%.
Yeah, and I think I'll just respond as to what I've seen a lot of mobile app projects that I've worked on. We always try and test as much as possible. Devices are not really are not free. They do cost money, and you know, what I've always done is test as much as possible on the variety of devices available to me and my team. There are other, you know, hardware device testing platforms out there, like Perfecto Mobile or Device Anywhere, which is now Keynote, that actually have banks of actual devices that you can deploy, but these solutions are really expensive. So the way what I kind of see a lot of customers doing now is test as much as you can, but then monitor in the wild and monitor your app for those bugs and errors, and really approach your testing as kind of more of a continuous integration type development project, even though we are creating actual software and deploying it as apps and going through the App Store to deploy each time, which is just 4 hours at most on Android. We do try and see, you know, kind of look at that as continuous integration and kind of defer. There's a funny quote I've heard here that we don't test, I don't test my code often, but when I do, it's in production. And you know, obviously with kind of more iterative, agile, Scrum type development methodologies, we want to push features out more fast and more quickly. And so in the last kind of, you know, 5-10 years in software development, we've seen more of an emphasis on testing less, launching faster, and then continuing to close that feedback loop of as you launch in the wild. Let's see here. Okay, thank you. Someone said thank you for clarifying mentioning BDD and TDD. I assume that's test-driven development. Okay, and we have, let's see here. We have another one here, a question. It's really about code profiling. And the attendee is asking if we can recommend any tools to use to profile the app. He says, I do have to monitor many threads in my app. What do you recommend? Do you want me to address that one, Godfrey?
Yep, if you could please, because mainly we just use Traceview for that, but I'm sure there's better out there, better solutions. So far away.
Yeah, I know that there's other companies out there that do provide more code profiling. I think one I'll just recommend that's been around for a while that I used in the past was SmartBear has some tools to do that. So you may want to take a look there, and that would just be my one off the top of my head. We'll follow up with this user here, attendee, and see about getting you some more information on that for actually code profiling as well. So let me see here. Okay. All right. Well, it looks like that's all the questions. So I think at this point we'll go ahead and wrap it up. Do you have any other closing comments, Godfrey?
No, I just want to say thanks again, and thank you for attending.
Okay. All right. Well, thank you, Godfrey. I just want to let everyone know we did record this entire session, so we'll be posting this recording online to the Crittercism YouTube channel, and to all attendees and registrants, we'll be sending out the link. So please feel free to pass it along to any of your colleagues and share this. Hopefully it was a valuable session. We are going to be raffling off the 10 books. So for everyone still on the line, thank you for staying on. You are now entered into our raffle. And we will be notifying you if you are a winner of one of those 10 books for Android Best Practices by Godfrey himself. So again, thank you very much. And if you do have any other questions, please, again, feel free to email us. You can either contact us at support@crittercism.com or marketing@crittercism.com, or find us on Twitter. You can, of course, always sign up and use some of the tools you did see at the end. It was another question here. Yes, those are that's Crittercism's product for Android app performance monitoring once you've launched it in the wild. So we do offer a free sign-up and free full 30 days to try out all of that on your app and see how those APIs are affecting your performance. So please go ahead and sign up for that. And again, thank you very much, Godfrey, and thank you all attendees, and look forward to seeing you in our next performance webinar. Thank you very much. Bye.